Here's another example involving three-dimensional geometry where we've got to find the height of a building. So, from a point X on the ground, the angle of elevation to the top of a building T is 22 degrees, where X is due south of T. From a point Y, 350 meters due east of X on the ground, the top of the building is on a bearing of 310 degrees. Calculate the height of the building, correct to the nearest meter. Okay, so there's quite a bit going on there, but when we draw a diagram that represents that information, you'll see again that the actual problem's not as hard or as difficult as it appears. Okay, I know it's quite wordy, so let's break it down one step at a time. So I'm going to draw the diagram on another board. Okay, so all right, so I might move this up a little bit. Okay, so we're going to build our diagram. Okay, so I guess the focus here is on this building. Okay, so this building and the top of the building is a point T. So what I might do is I'm going to draw a compass rose first, and the reason why I'm going to draw a compass rose is because there's also directions mentioned as well, or bearings. So this point X on the ground, okay, it's somewhere south of T. So let's draw that in. Okay, so let's say there's our building. I might just draw the building here. Okay, so that's the top of the building. Okay, and this point X is due south of T, and there's an angle of elevation there of 22 degrees. So what I'm going to do is I'm going to draw a compass rose, but I'm going to draw a compass rose, I'm going to simulate it or sort of draw it in perspective so that it's as if the compass rose is on the ground. Okay, so something like that. So there's north and there's south. And there's a point X, okay? Point X on the ground, and it has an angle of elevation to the top of the building of 22 degrees. And the building is, or forms an angle of 90 degrees with the ground. Okay, so this would be east this way as well. Okay, so I might just draw east there. Okay, and that's west. Okay, so hopefully that's starting to make a little bit of sense to you. Now let's have a look at the next part of the problem. Okay, so at least the next little next bit of information. So it says from a point Y, okay, 350 meters due east of X on the ground, the top of the building is on a bearing of 310 degrees. Okay, so this point Y is due east of X. So east is in this direction, isn't it? So it's parallel to this east-west line there. Okay, so let's draw that out. Okay. Okay, and there's our point Y. Point Y is 350 meters away from X. Okay, and making sure that as we're building our diagram, we're checking to see that we are, in fact, using the correct information on the diagram as well. Okay, again, another source of error is when we're building our diagram, we're copying the wrong information, or we make a mistake, or we sort of like a transcription error. Okay, sort of a copying error there. Okay, so I think so far so good. And we're also told that the top of the building T is on a bearing of 310 degrees. So I'm just going to draw another compass rose here. So this is parallel. Okay, there's north again. There's south. Okay, and we're told that the top of the building, which is in line with the base of the building, is on a bearing of 310 degrees. So I might just draw this. Okay. And we're asked to find the height of the building. So what I might do is I might just put another letter here. So this is the base of the building. Have I used the letter B? No, I haven't. Let's call that B for base of building. There. Okay, so we want to find the height BT, which is the height of the building. Okay, so hopefully so far it's making some sense. Now, we need to also add in a right angle somewhere. And there is a right angle that's implied. If we're told that point Y is directly east of X, of point X, okay, the east-west line and the north-south line are 90 degrees, are perpendicular to each other. So there's a 90 degree there. Okay, so we have a triangle here, BSY, with a known side and an angle that in fact we can find. So what I'm going to do is I'm going to just sort of start adding in some extra information now beyond what's in the question to try to help us solve this now. So in fact, I don't actually need the question anymore. I think we have enough information now that we can just work from this diagram. Okay, so do you see where where a lot of the thinking is required and a lot of the processing is required to convert this, okay, this text into this, okay, is really the skill that we're talking about here. The other part of the skill is being able to think in 3 dimensions, of course. Okay, so we want the height of the building, so BT. Let's give it a pronumeral to make it a bit easier. Let's give that pronumeral X. Okay, to find X, okay, I need a known side on this triangle SBT. I have an angle of elevation here of 22 degrees. Okay, but that's not enough. I need something else. I need another side. Okay, I need a known side. So SB, we may be able to find that. In fact, we can. We can use our bearing here, okay, to help us calculate the angle theta that's inside the triangle. So we're going to convert the bearing now into an angle that is inside triangle BSY. So I'm going to draw triangle BSY here. Okay, there's Y. Okay, okay, sorry, that's not there, that's south there. Sorry, it should be XY, sorry. So that's BXY there. Okay, that's what happens when you put labels close to each other. Okay, so it's actually BXY, and there's B here. Yep, south is down here. Obviously, that's sort of the north-south line there. That's this line here. Okay, XY is 350 meters. Okay, now we have a bearing of 310 degrees. Okay, so that's this bearing here. Okay, and that's north. Okay, so let's see, and we need this angle theta here. Okay, so that's north, all the way to west is 270 degrees. Okay, and to go from 270 to 310, theta, okay, is equal to 310 minus 270. Okay, and that'll give us 40 degrees. Okay, so we now have an angle inside the triangle. Okay, so this is 40 degrees that we can now use to find BX. Okay, which is, and again, a common side with triangle XBT. Okay, so I might draw a triangle XBT now. Okay, so there's T, top of the tower, there's B, and there's X. Okay, so this BX here, okay, so let's call that, maybe give it another pronumeral, let's call that pronumeral Y, okay, is really the same as this pronumeral there. Okay, and that's this pronumeral here. Okay, they're all the same side, BX, BX, BX. Okay, and let's see if we can now use triangle BXY to find Y. Okay, so in triangle BXY, okay, we can use the tan ratio again. Okay, so tan of 40 degrees, okay, is equal to opposite over adjacent, so that's going to be bx over 350. Okay, bx is equal to 350 multiplied by tan 40. Okay, and I'm going to round this to 2 decimal places, okay, just to maintain a little bit of accuracy. I know we have to work to the nearest meter. So let's, okay, we got 293.68. Okay, you can use all the decimal places, but I might just use, actually, no, I might use 3 decimal places, just make it a little bit more accurate. So 293.685. Okay, so that's this length there. That's 293.685 meters. Okay. Now we can use bx to then find the height of their building. Okay, so we have angle TXB. Okay, and that's 22 degrees. Okay. Now we can find BT, which is our height of the building. Okay, so again, we can use the tan ratio here. So tan 22 degrees is equal to BT over 293.685. Multiplying both sides by 293.685, BT is equal to 293.685 multiplied by tan of 22 degrees. Okay, tan of 22 degrees, and we get 118.656 meters, which to the nearest meter is 119 meters.